Okay, so what we're going to do is look at this. For you guys, what you're going to need to do is you're going to need to actually take this solid triangle on the right, or if it's on the left, and you're going to have to rotate it and translate it, dilate it, mirror image it in order to get it to fit into this triangle. So obviously with this one, it needs to be dilated larger, it needs to be mirror imaged, it needs to be rotated, and then it needs to be translated over. Okay, so those are the three things. Those are the four things that are going to need to happen to this particular triangle to get it to fit in this dashed line area. Okay, now looking at part A, what you're really doing in part A is just creating a relationship with each of the sides of the triangles to see if the ratios are the same, okay? Or this may be part B for yours, I'm not sure, but just match things up. So for mine, I have BA over PQ is going to equal some relationship and ratio. I have AC over QR, which is going to be a relationship or a ratio, and BC over PR. All right, so let's look at this. I've got BA, which is this distance right here. Okay, so there's BA, and it is 35. Over PQ, and PQ is right here. Okay, and it is 28. Now I look at 35 and 28, and I know both are divisible by 7. Okay, and so when I do this, I'm going to get 35 divided 7 is 5, and 28 divided 7 is 4. So I know 5/4 is the ratio for BA over PQ. Let's go over to AC and QR. So let's see here. AC is this distance here, and that is 40, over QR, which is this distance right here, which is 32. Both of those are even, so that's going to be 20 over 16. Well, 20 over 16 are still even, so I can divide by 2 again to get 10 over 8. Well, those are still even, so I can actually divide one more time and get 5 over 4. Or I could just look at this and go, oh, well, that's divisible by 8, and that is also divisible by 8. So 40 divided 8 is 5, and 32 divided 8 is 4. All right? So you're always looking for the greatest common factor to do your simplification with. Finally, let's hit the last set here. And so we're going to have BC. So here's BC right there. So that's 20 over PR right here, which is 16. And 20 and 16 are both divisible by 4 as the greatest common factor. And so I get 5 over 4 again. And so what we're seeing is that the ratio between the sides of both these triangles are the same. And that's really what you want, because if you're going to proportionally shrink one side, you have to proportionally shrink all sides to keep the triangle similar. So if you have all sides proportional, all sides have the same proportions. Basically, they all are 5/4 and 5/4 and 5/4, or 1/2 and 1/2 and 1/2. Then you know that these triangles are similar. So let's go to part B. I'm actually going to just zoom this down so we can still see this. Part B is simply looking for the congruence between these angles of one triangle and the angles of the triangle in the other one. So if you look at this, here's P and R, and what happened was this got flipped, right, and just got rotated. So let me just see here. So there's P and R, and so they kind of got rotated and placed like this, right? So here's P and R. It flips. Actually, in this case, no, I'm sorry. In this case, this one's P and R, and these just kind of slide right over because, again, Q right here and P these ones actually, Q flips to over here, and then this just slides like that. So you can see A and Q are actually the same, P and B are the same, and R and C are the same. So angle P relates to angle B, or is congruent with angle B. Angle Q is congruent with angle A, and angle R is congruent with angle C. And so therefore, for part C, you would just simply say that angle PQR and, sorry, not angle, triangle, PQR and triangle BAC are similar.